January 10th, 1941. Charles Sorensen stands in the bright California sun outside Consolidated Aircraft's San Diego plant, watching men assemble a B-24 Liberator bomber piece by piece on an outdoor steel fixture. The 60-year-old production chief has spent 4 decades perfecting mass manufacturing at Ford Motor Company. He built the world's first moving assembly line. He created the Rouge complex, where 100,000 workers could transform raw iron ore into finished automobiles in 48 hours. Now, squinting against the Pacific glare, he watches aircraft workers spend 4 hours just to hang a single engine. They're using a surveyor's transit mounted in the back of a pickup truck, adjusting the bomber's centerline by hand, one painstaking measurement at a time. The heat is distorting the steel fixtures. No 2 planes come out identical. Sorensen's jaw tightens as he calculates the mathematics in his head. At this rate, America will lose the war before it begins. But what the San Diego engineers don't know is that Cast Iron Charlie, as Henry Ford calls him, has already conceived something impossible in his mind. Something that will turn aircraft production from medieval craftsmanship into industrial symphony. Something so audacious that even his own colleagues will call it reckless. 1 bomber every 63 minutes. From raw aluminum to wheels leaving the runway. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This is the story of how one Danish immigrant's sketch on hotel stationery became the weapon that broke Nazi confidence. How a factory mocked as "Will it run" transformed into the beating heart of America's arsenal. And how precision craftsmanship met assembly line fury to prove that democracy could outbuild tyranny, 1 bomber at a time. Long before Sorensen stood in that California sun, he had learned that nothing was impossible if you understood the mathematics of motion. Born in Copenhagen in 1881, he arrived in America at age 4, the son of a carpenter who believed in American opportunity. By 20, Charles Sorensen was a pattern maker at the Jewett Stove Works in Buffalo, New York, shaping wooden molds for cast iron with hands that understood precision down to the thousandth of an inch. In 1904, a custom foundry in Detroit hired him. That's where he first met Henry Ford, a restless entrepreneur with an obsession about making automobiles affordable for working families. Ford needed someone who understood casting, who could think systematically about moving metal through factories like water through pipes. Sorensen joined Ford Motor Company in 1905, starting as a pattern maker but quickly rising through raw talent and relentless work ethic. The breakthrough came on a Sunday in 1910 at the Piquette Avenue plant. Sorensen and another, Ford executive, Charles Lewis, tested an idea that would change manufacturing forever. They took a rope, looped it over Sorensen's shoulders, and used it to tow an automobile chassis through the factory in a straight line, while other workers added parts along the way. By the end of that Sunday afternoon, they had proven that moving the product to the workers, rather than moving workers to the product, cut assembly time from 12 hours to 90 minutes. The moving assembly line wasn't just faster. It was revolutionary. It meant that ordinary workers performing simple, repetitive tasks could build complex machines with consistency no craftsman could match. It meant precision through process rather than individual skill. It meant American democracy could unleash industrial forces that monarchies and empires, dependent on guilds and master craftsmen, could never replicate. Henry Ford called him Cast Iron Charlie because Sorensen invented methods to use metal patterns instead of wooden ones in mass production foundry work. The nickname stuck, but it also captured something essential about the man himself. He was hard, uncompromising, brilliant in organization, and explosive in temper. Workers feared him. Executives resented him. But Henry Ford trusted him absolutely because Sorensen delivered miracles on schedule. By the late 1930s, Charles Sorensen had become Ford's production czar, the man who made the impossible routine. He oversaw the Rouge complex, the largest industrial facility on Earth, where 100,000 workers transformed raw materials into 10,000 cars daily. He understood systematic flow, precise timing, and mathematical efficiency better than any manufacturer alive. He had spent 35 years perfecting the art of making complex products move through factories like clockwork. But in January 1941, America faced a crisis that automobiles couldn't solve. Europe was burning. France had fallen. Britain stood alone, against Nazi Germany. President Roosevelt had called for 50,000 aircraft annually to support the democracies fighting fascism. The problem was that American aircraft production operated more like medieval cathedral building than modern manufacturing. Consolidated Aircraft, one of the nation's leading bomber manufacturers, built their massive B-24 Liberators outdoors, using methods that hadn't changed in decades. When the Roosevelt administration approached Ford Motor Company about manufacturing components for the B-24 program, Sorensen saw an opportunity. Not just to build parts, but to revolutionize aircraft production itself, using the assembly line principles he had spent a lifetime perfecting. Edsel Ford, the company's gentlemanly president and Henry's only son, agreed to send Sorensen to San Diego to observe Consolidated's operations and assess whether Ford could contribute to bomber production. What Sorensen witnessed in California that January morning simultaneously appalled and inspired him. The B-24 Liberator was an engineering marvel. 67 feet long with a 110-foot wingspan, 4 massive Pratt & Whitney engines producing 1,200 horsepower each, capable of carrying 8,000 pounds of bombs across 2,000 miles. The bomber contained 30,000 separate components assembled into 488,000 individual parts. It was the most complex machine America had ever attempted to mass produce. But Consolidated's production methods belonged to another century. Inside the plant, Sorensen watched skilled craftsmen hand-fit wing sections and fuselage portions using techniques unchanged since the First World War. Outside, under the bright sun, workers assembled final aircraft on structural steel fixtures that warped in the California heat, making it impossible to turn out 2 planes with identical measurements. Every bomber required constant adjustments, individual fitting, custom calibration. The final assembly was made outdoors because the aircraft was simply too large for Consolidated's existing buildings. Workers used surveyors' transits balanced on pickup truck beds to align propeller shafts, squinting through optical sights while other men adjusted engine mounts by hand. One engine installation required 4 hours of painstaking work. One complete bomber required months of skilled labor. At this rate, Consolidated could produce perhaps 1 B-24 daily at maximum efficiency. The Consolidated engineers who showed Sorensen around explained their challenges with professional resignation. Aircraft, they insisted, required precision far beyond anything achievable through mass production methods. Each wing must be hand-fitted to account for metal variations. Each rivet must be individually placed and inspected. Each control surface must be calibrated by master mechanics who understood the aerodynamics of flight. Quality and speed were inversely related in aircraft manufacturing, they said. You could have one or the other, never both. Sorensen listened politely, his weathered face betraying none of his thoughts. But behind those pale blue eyes, mathematical calculations were running at high speed. He saw the B-24's complexity not as an obstacle, but as an opportunity. Every one of those 30,000 components could be broken down, standardized, and manufactured separately using precision jigs and fixtures. Every assembly process could be reduced to simple, repetitive tasks that ordinary workers could master in days rather than years. The key insight came that evening back at his hotel. Sorensen sat at the desk in his room, pencil in hand, staring at blank stationery. The Consolidated engineers were wrong about one fundamental assumption. They believed aircraft had to be built like cathedrals because that's how aircraft had always been built. But Sorensen understood something they didn't. Complexity didn't require craftsmanship. Complexity required system. A Ford V8 automobile engine contained hundreds of precisely machined parts, working together at thousands of revolutions per minute. Yet Ford produced those engines on assembly lines, using workers who had never built engines before. The secret wasn't in the workers' skills. It was in the jigs, fixtures, and processes that made precision automatic. What worked for engines could work for bombers. Sorensen began to sketch. Not detailed engineering drawings, just rough concepts showing how a massive factory might flow. A building so large you could fit multiple football fields inside, an assembly line stretching a full mile from end to end. Specialized stations where sub-assemblies would be manufactured separately, then converged at precise moments in the production sequence. Wings moving on overhead cranes, fuselages rolling on tracked dollies, every component arriving exactly when needed, fitted automatically using massive precision fixtures. The more he sketched, the more clearly he could see it. Not just a factory, but a choreographed industrial ballet where 40,000 workers moved in systematic harmony, where raw aluminum sheets entered one end and complete bombers rolled out the other 63 minutes later, where American industrial democracy would demonstrate that ordinary people, properly organized, could outproduce any system dependent on elite craftsmen and master mechanics. By midnight, Sorensen had filled the hotel stationery with sketches that outlined Willow Run, though he didn't know that name yet. He had designed in rough form the largest factory building ever constructed, the most sophisticated assembly line ever conceived, and the most audacious manufacturing project in human history. He had created the blueprint for how democracy would win the war, not through superior skill or courage, but through systematic application of assembly line principles to aerial warfare. He couldn't sleep. His mind kept building bombers in the darkness, calculating production rates, designing fixture systems, organizing workflow patterns. By dawn, he was exhausted but certain. America could build one B-24 bomber every hour, not despite the aircraft's complexity, but because systematic mass production could achieve precision impossible through traditional craftsmanship. At breakfast the next morning with Edsel Ford, Sorensen was somewhat woozy from lack of sleep but blazing with conviction. He spread his sketches across the table and outlined the bomber an hour proposition. Edsel, who possessed his father's vision without the old man's explosive temperament, studied the sketches in silence for several minutes. Then he looked up at Sorensen with complete confidence. Ford Motor Company would build such a plant. Not just manufacture bomber components, but construct complete aircraft using revolutionary mass production methods. Edsel assured Sorensen of his full support and promised to convince his father. They had exactly 1 hour before a meeting at Consolidated to present their proposal. $200 million backed only by penciled sketches on hotel stationery. The largest single production contract in American history, wagered on Charles Sorensen's conviction that aircraft could be mass-produced like automobiles. Major Reuben Fleet, Consolidated's founder and president, listened to Sorensen's presentation with barely concealed skepticism. Fleet was an aviation pioneer, a man who had built his company through engineering excellence and aeronautical expertise. The idea that an automobile manufacturer could waltz into aircraft production and revolutionize overnight what Consolidated had spent decades perfecting struck him as arrogant fantasy. "You can't stamp out airplanes like automobile fenders," Fleet objected, his voice sharp with professional indignation. "Every rivet must be perfectly positioned, every weld must be flawless. You cannot mass-produce precision, Mr. Sorensen. Aircraft require craftsmanship that your assembly line workers simply don't possess." Sorensen had anticipated this resistance. He understood that he was challenging not just Consolidated's methods, but the entire aviation industry's fundamental assumptions about manufacturing. He responded not with argument, but with questions. How long did it currently take to produce one B-24? How many skilled workers were required? What were the bottlenecks limiting production? Fleet's answers confirmed what Sorensen already knew. Consolidated was producing approximately one B-24 every 3 days, using methods that required highly skilled craftsmen spending countless hours on individual aircraft. They were already struggling to meet current production demands. Roosevelt's call for exponentially increased aircraft production was mathematically impossible using traditional methods. Sorensen didn't argue. He simply stated his proposition. Ford would take complete responsibility for B-24 production, not just components. They would design and build the largest factory ever constructed. They would develop revolutionary assembly line methods that maintained aircraft precision while achieving automotive production rates. They would deliver one bomber every hour within 18 months. The room fell silent. Fleet and his engineers exchanged glances that mixed skepticism with something that might have been hope. America desperately needed bombers. Britain was fighting for survival. Germany's industrial machine was producing aircraft at accelerating rates. If Sorensen was even half right, his proposal could change the strategic balance of the coming war. The contracts were signed in February 1941, launching the most ambitious industrial project in American history. Sorensen returned to Michigan with authorization to build not just a factory, but an entirely new way of thinking about aircraft production. The government would contribute $200 million. Ford would provide the land, the expertise, and the unshakable conviction that systematic mass production could accomplish what traditional craftsmanship never could. By April, construction had already begun on 4 flat acres of Michigan farmland outside the village of Ypsilanti, 25 miles west of Detroit. Sorensen chose this location for practical reasons. It provided enough space for the massive factory complex he envisioned, plus an adjacent airfield where completed bombers could immediately take flight. The land belonged to Henry Ford personally, who owned extensive farms throughout southeastern Michigan. The old man donated the property for the war effort, though technically Ford Motor Company would build the facility and lease it back from the government's Defense Plant Corporation. Sorensen brought in Albert Kahn, the legendary industrial architect who had designed Ford's Highland Park plant and the massive Rouge complex. Kahn listened to Sorensen's requirements with the professional calm of a man who had spent decades making the impossible concrete. A main building spanning 3.5 million square feet, an assembly line stretching exactly 1 mile from end to end. Ceiling heights sufficient for overhead cranes to move bomber components. Specialized bays for sub-assembly work. Climate-controlled areas for precision manufacturing. Kahn translated Sorensen's vision into architectural reality, creating an L-shaped structure required by easement issues with adjacent property. The main building would be more than 1/4 mile wide and 1/2 mile long, covering 65 acres under a single roof. It would be the largest enclosed space ever constructed, large enough to contain 42 football fields with room to spare. The facility would consume enough steel to build a battleship, enough concrete to pave a highway from Detroit to Chicago, enough electrical power to light a city of 50,000 people. But the building itself was just the beginning. Sorensen's real innovation was the systematic workflow design that would transform raw materials into finished aircraft through carefully choreographed sequential operations. He envisioned breaking the B-24 into major sub-assemblies that could be manufactured in parallel, then converged at precise moments on the main assembly line. Wings would be built in specialized jigs in one section of the plant. Fuselages would be constructed in another area. Tail sections, engine mounts, landing gear, control surfaces. Each major component would have its own dedicated manufacturing zone, where teams of workers performed repetitive operations designed for speed and precision. Then, at scheduled intervals, overhead cranes would deliver these sub-assemblies to the main line where they would be joined together with mechanical precision. The scale was staggering, but Sorensen had learned over 4 decades that scale was simply mathematics applied systematically. The plant would require 100,000 workers at peak production, more people than lived in many American cities. It would need specialized tools and fixtures weighing hundreds of tons. It would consume trainloads of aluminum, rivers of aviation fuel, mountains of rivets and fasteners. Most revolutionary was Sorensen's vision for precision through process rather than individual skill. Traditional aircraft manufacturing relied on master craftsmen who could hand-fit components with tolerances measured in thousandths of inches. Sorensen planned to design massive jigs and fixtures so precise that ordinary workers could install major components in minutes without measuring anything. The jigs would hold everything in perfect position automatically. Workers would simply operate pneumatic tools following standardized procedures. This approach required something unprecedented in aircraft manufacturing. Every component must be standardized to exact specifications. Unlike Consolidated's practice of fitting each part individually to compensate for manufacturing variations, Sorensen demanded that parts be machined with such precision that any wing would fit any fuselage, any engine mount would align perfectly with any wing, any tail section would mate flawlessly with any fuselage. This meant tolerances tighter than anything achieved in automotive manufacturing, but Sorensen believed American machine tool industry could deliver such precision if properly challenged. The technical obstacles seemed overwhelming to traditional aircraft engineers. The B-24 contained 30,000 separate components. Consolidated couldn't even provide complete engineering drawings for most of them. Their blueprints were incomplete, filled with discrepancies, marked with unfamiliar symbols and notations. Countless design details existed only in the memories of Consolidated's plant foreman, who had built dozens of bombers using knowledge accumulated through experience. Sorensen's response was characteristically systematic. He had 2 complete B-24 bombers flown to Michigan, where they were disassembled piece by piece in Ford's engineering laboratories. A 1,000-member tool design group worked around the clock 7 days a week for almost a year, creating 3-dimensional schematics of every one of the bomber's 30,000 components. They generated 5 million square feet of blueprints in the process, more engineering drawings than Ford had produced for all its automobile models combined. These detailed drawings guided the custom design of 1,600 machine tools and 11,000 fixtures, some standing 60 feet tall, that would stamp, mill, drill, broach, and grind parts to thousandths of an inch tolerances. It was the largest single tooling project ever attempted. The precision equipment alone cost more than Consolidated had invested in their entire San Diego facility. But even as Sorensen's engineering teams worked frantically to create production-ready designs, dark clouds gathered over the project. By autumn 1941, construction of the Willow Run plant was behind schedule. The building's unprecedented size created unexpected structural challenges. Steel shortages caused by military demands slowed fabrication of the massive framework. Labor disputes disrupted construction schedules. More troubling were the constant design changes Consolidated demanded. As an aircraft company, Consolidated continuously refined the B-24 based on combat experience and evolving military requirements. These modifications made perfect sense from an engineering perspective. Each change improved the bomber's performance, safety, or capability. But each change also required Ford's tooling teams to redesign fixtures, modify assembly procedures, and update training programs. 10,000 of the 30,000 engineering drawings Ford's teams created became obsolete before the ink dried. Tools designed for specific components no longer fit when Consolidated changed dimensions. Assembly sequences had to be completely reorganized when new equipment was added. What Sorensen later called constant meddling from Consolidated was keeping things from moving forward, turning what should have been systematic production into chaotic improvisation. Then, on December 7, 1941, everything changed. Japanese aircraft struck Pearl Harbor, sinking America's battleships and killing thousands of servicemen. 4 days later, Germany declared war on the United States. America was suddenly fighting a 2-ocean conflict against enemies who had spent years preparing for war. The pressure on Willow Run intensified beyond imagination. Roosevelt's call for 50,000 aircraft annually now seemed timid. The military needed bombers immediately, in quantities that seemed mathematically impossible. Willow Run became not just an industrial project but a test of American democracy itself. Could ordinary workers, properly organized, outproduce totalitarian systems built on slave labor and military discipline? Could systematic mass production defeat craftsman tradition backed by years of preparation? Charles Sorensen, now 60 years old, worked 18-hour days driving the project forward with relentless determination. Critics whispered that Cast Iron Charlie had finally bitten off more than he could chew. Traditional aircraft executives predicted humiliating failure. The mathematics seemed impossibly against him. Even with the massive Willow Run facility nearing completion, the sheer complexity of organizing 40,000 workers to build the world's most complex weapon seemed overwhelming. But Sorensen had spent 40 years making the impossible routine. He understood something his critics didn't. Industrial war would not be won by individual genius or traditional craftsmanship. It would be won by systematic application of assembly line principles to every aspect of production. It would be won by breaking complexity into simple, repetitive tasks that ordinary Americans could master and perform with mechanical precision. The skeptics would soon learn what Cast Iron Charlie already knew. Democracy's greatest weapon wasn't courage or skill. It was organization. And Charles Sorensen was about to prove that systematic mass production could turn ordinary factory workers into an army of industrial warriors more devastating than any military force on Earth. The war had begun. The clock was ticking, and Willow Run was about to show the world what American industrial democracy could accomplish when properly unleashed. May 15th, 1942. The date was circled in red on every calendar at Willow Run. This was the day Ford had promised to deliver its first B-24 bomber. Workers arrived at dawn expecting celebration. Engineers prepared for the historic moment when the first Ford-built Liberator would taxi down the runway, proving that automobile manufacturing could revolutionize aircraft production. The runway remained empty. The massive assembly line, stretching a full mile through the world's largest factory, stood silent except for the sound of frustrated workers trying to make sense of incomplete tooling and constantly changing specifications. The bomber that was supposed to fly that May morning existed only as scattered components in various stages of assembly, surrounded by engineers scratching their heads over blueprints that no longer matched the aircraft they were trying to build. Outside the factory gates, newspaper reporters who had arrived to document American industrial triumph instead witnessed American industrial chaos. By week's end, headlines across the nation mocked Ford's failure. The Detroit Free Press dubbed the facility Willow Runaround. Aviation industry executives who had opposed Sorensen's revolutionary approach barely concealed their satisfaction. Traditional aircraft manufacturers, who had warned that mass production was fundamentally incompatible with aviation precision, felt vindicated. The problems were deeper than anyone outside Willow Run understood. Consolidated Aircraft, still technically in charge of B-24 design, was making changes to the bomber specifications almost daily. Every modification made perfect sense from an engineering perspective. Combat experience was revealing weaknesses that needed addressing. New defensive armament was required. Better engines became available. Improved control systems were developed. Each change made the B-24 a better bomber. But each change also destroyed months of Ford's preparation. Tools designed for specific wing dimensions became useless when Consolidated changed the wingspan by inches. Assembly jigs built for particular engine mounts couldn't accommodate new power plants with different mounting configurations. Training programs teaching workers to install specific components had to be completely redesigned when those components were replaced by improved versions. All the tooling they designed now doesn't work because Consolidated changed the airplane every day, Sorensen told anyone who would listen, his voice edged with frustration, unusual for a man known for unshakable confidence. This gives Ford a 6-month delay in their production schedule because they thought they'd have all this equipment ready. 200 engineers were working shifts around the clock, producing 5 miles of engineering drawings daily, trying to translate Consolidated sketches and templates into production-ready blueprints that Ford's workers could actually use. But Consolidated's changes were coming faster than Ford's teams could document them. It was like trying to build a bridge while someone upstream kept changing the river. The delay from May to September, 4 months of painful silence while the nation waited for bombers, provided ammunition for every critic who had opposed the project. Charles Lindbergh, America's most celebrated aviator, publicly questioned whether automobile manufacturers could ever understand the precision required for combat aircraft. Congressional representatives demanded investigations into why Ford was wasting taxpayer money on fantasy projects. The media, which had initially celebrated Willow Run as the embodiment of American industrial might, turned savage. Newspapers ran detailed analyses showing that at current production rates, Ford would need more than a century to produce the bombers America needed. Editorial cartoons depicted Henry Ford and Charles Sorensen as out-of-touch industrialists who had promised miracles and delivered failure. The phrase "Willow Runaround" entered common usage as shorthand for ambitious projects that collapsed under their own weight. Inside the plant, the reality was even more brutal than the headlines suggested. The facility itself was magnificent, the largest enclosed space on Earth, with assembly lines stretching to the horizon and specialized bays for every conceivable manufacturing operation. But magnificent buildings don't build bombers. Trained workers following systematic procedures build bombers, and in mid-1942, Willow Run had neither. The plant was located 35 miles west of Detroit, practically in the middle of farmland. This created immediate labor problems. Ford needed tens of thousands of skilled workers, but the factory sat an hour's drive from Detroit's industrial neighborhoods where such workers lived. Wartime gasoline and tire rationing made daily commuting nearly impossible for many families. In one brutal month, Ford hired 2,900 workers but lost 3,100 to resignation, unable to sustain the grueling commute or willing to take easier jobs closer to home. The federal government responded by constructing emergency housing near the plant. Willow Run Lodge provided dormitory space for single workers. Willow Run Village offered apartments for families. By the end of 1943, temporary housing sheltered more than 15,000 people, roughly equal to Ypsilanti's entire population. But these hastily built communities lacked businesses, entertainment, or community infrastructure. Workers described the area as a dull, isolated place where there was nothing to do except work and sleep. Labor difficulties extended beyond housing and commuting. The plant was designed for 100,000 workers at peak production, but in 1942 it struggled to maintain 40,000. Many experienced workers were being drafted into military service. Their replacements were often people who had never seen the inside of a factory before. Farmers from Kentucky, housewives from Detroit suburbs, teenagers too young for military service, African Americans migrating north for industrial opportunities. These workers, many of whom had purchased their first pair of shoes upon arriving in Michigan, were expected to master complex assembly operations, building the world's most sophisticated bomber. Traditional aircraft manufacturing relied on craftsmen who had trained for years. Sorensen's system required ordinary people to learn specialized tasks in days. The collision between theory and reality was producing chaos on the assembly line. Henry Ford himself created additional problems with his rigid principles. The old man, now 78 years old and increasingly erratic, was violently anti-union. This led to serious labor difficulties, including a massive strike that shut down portions of the plant. Ford also refused on principle to hire women, insisting that factory work was men's work. He finally relented, probably more because so many potential male workers had been drafted than any sudden change of principle. By May 1942, 15% of Willow Run's workforce consisted of women earning the same 85 cents per hour as men for identical work. Rose Will Monroe, a rivet gun operator from Pulaski County, Kentucky, appeared in a Ford promotional film and became one of thousands of women collectively known as Rosie the Riveter. These women mastered complex tasks that traditional aircraft engineers insisted required male strength and years of training. They operated pneumatic riveters weighing 40 pounds. They assembled intricate control systems requiring steady hands and infinite patience. They worked 9-hour shifts, 6 days a week, transforming Sorensen's systematic procedures into physical reality one rivet at a time. But even as the workforce gradually improved, production remained agonizingly slow. Only 56 complete aircraft were built in all of 1942, not 56 per month, 56 total. For an entire year, the first series of Willow Run Liberators, designated B-24E models, were so delayed by production problems that many were obsolete by the time they were finished. Most went to training squadrons rather than combat units, teaching American pilots to fly bombers while overseas forces desperately needed the actual aircraft. Then came the congressional investigation that nearly destroyed everything. Senator Harry S. Truman, leading a committee charged with rooting out graft and corruption in defense industries, was sent to examine Willow Run. The government was seriously considering nationalizing Ford Motor Company to take over the plant. Truman's team arrived expecting to find evidence of incompetence, waste, or fraud justifying federal seizure of the facility. A 1943 committee report issued devastating findings. Ford Motor Company had created a production line that too closely resembled an automobile assembly line, despite the warning of many experienced aircraftmen. The jumping of an automotive company into aircraft production posed serious quality problems. The plant was beset with labor difficulties, high absentee rates, and rapid employee turnover. Ford employees were used to automobile mass production and found it difficult to adapt these techniques to aircraft production. The criticism was professionally worded but politically explosive. It confirmed every skeptic's warning that automobiles and aircraft were fundamentally different products requiring fundamentally different manufacturing approaches. It suggested that Sorensen's revolutionary vision was based on arrogance rather than engineering reality. It threatened to end the Willow Run experiment before systematic mass production could prove its worth. But Truman's investigation, thorough and fair-minded, discovered something unexpected. The delays weren't Ford's fault. What investigators found was that Consolidated Aircraft, still possessing design authority over the B-24, was being allowed to call Willow Run and demand changes whenever they wanted. And they did. Every single day, Truman's committee gave Willow Run a clean bill of health, noting that constant meddling from Consolidated was keeping things from moving forward. This finding changed everything. The government ordered Consolidated to freeze the B-24 design and allow Ford to concentrate on production rather than constantly redesigning tooling. Ford was authorized to decentralize operations, with many parts assembled at other Ford plants and subcontractors, while Willow Run concentrated on final aircraft assembly. Most importantly, Charles Sorensen was given clear authority to implement his systematic production methods without outside interference. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By autumn 1943, the top leadership role at Willow Run had passed from Charles Sorensen to Meade Bricker, allowing Sorensen to focus on systematic refinements throughout Ford's defense production network. But Sorensen's revolutionary principles remained the foundation of everything Willow Run attempted. Finally freed from constant design changes, finally supported rather than undermined by government oversight, the plant began to discover its rhythm. The transformation started with the bugs being worked out of manufacturing processes through obsessive attention to detail. Every bottleneck was analyzed. Every delay was studied. Every inefficiency was eliminated through systematic problem-solving. Sorensen's teams spent months perfecting what he called production rhythm, the synchronized timing that would allow thousands of workers to function as a single coordinated organism. The breakthrough came through innovations that revolutionized aircraft manufacturing. The most impressive was Ford's technique for assembling the B-24's center wing section, the massive structure where the four engines mounted and where the aircraft's fuel tanks were housed. This component was critical to the bomber's structural integrity and its most complex subassembly. Consolidated's traditional method required building each wing with its own temporary jig to hold the structure in place during assembly. Skilled workers would spend 250 man-hours per wing, carefully fitting hundreds of individual ribs, spars, and skin panels. Every wing was slightly different because human assembly introduced inevitable variations. Quality control meant inspecting each completed wing individually and making corrections as needed. Sorensen's team created a permanent jig into which wings could be moved in and out by overhead crane. This massive precision fixture, weighing several tons and standing 2 stories tall, held every component in perfect position automatically. Workers no longer needed to measure anything. They simply loaded prefabricated components into the jig, operated pneumatic riveters following standardized procedures, and the wing emerged with tolerances of 0.005 of an inch. Consolidated's method required 250 man-hours. Ford's needed 1 hour. This single innovation represented everything Sorensen had promised. Precision through process rather than individual skill. Speed through systematic organization rather than rushing workers. Quality through elimination of human variation rather than depending on craftsman expertise. It was the assembly line principle applied to the most complex component of the world's most sophisticated bomber. Similar innovations spread throughout the plant. Fuselage sections that traditionally required dozens of workers' days of labor were now assembled in specialized jigs by small teams in hours. Tail sections were manufactured using stamping dies that produced identical components with automotive precision. Engine installations that Sorensen had watched take 4 hours in San Diego now required 90 minutes using overhead cranes and precision mounting fixtures. The numbers began telling a story of systematic acceleration. Ford built 37 planes in January 1943, 70 in February, 96 in March, 146 in April. By November 3, 1943, employees celebrated as Willow Run turned out its 1,000th finished B-24 bomber. Critics who had mocked the plant's slow start fell silent as the production curves bent upward with mathematical precision. The assembly line itself became a thing of mechanical beauty. Picture a bomber fuselage, 67 feet of aluminum structure weighing several tons, moving slowly through specialized stations on tracked dollies. At the first station, workers install the bomb bay structure. At the next, electrical systems are threaded through the airframe. Further down, hydraulic lines are installed, gun mounts are added. Control cables are routed. Each station performs one specific operation taking precisely timed minutes. Overhead cranes deliver wing sections at scheduled intervals, lowering them into position where they mate with fuselage fittings designed with such precision that bolts slide through pre-drilled holes without adjustment. Tail sections arrive from their dedicated assembly area exactly when needed. Engine installations happen in 4 simultaneous operations. 1 power plant at a time, lowered by crane and bolted to mounting brackets that align perfectly every single time. The rhythm was hypnotic, 40,000 workers moving in synchronized patterns, components flowing through the mile-long factory in carefully choreographed sequences, raw aluminum entering one end of the building, shaped by massive presses into structural components. Sub-assemblies converging at precisely calculated moments. Complete bombers emerging from the final station where tires met runway, ready for test pilots to fly them directly to military bases. By mid-1944, Willow Run was producing bombers faster than the military could process them. Pilots and crew members slept on 1,300 cots at the adjacent airfield, waiting for bombers to roll off the assembly line so they could immediately fly them to operational squadrons. The production statistics that had seemed impossibly optimistic in 1941 were becoming routine reality. The plant went from building 1 plane monthly in October 1942 to producing nearly 500 monthly by June 1944. At peak efficiency, Willow Run was generating bombers at rates that defied imagination. The capability existed to create 650 B-24 seconds monthly, one every 45 minutes, though the Army ultimately slowed production to 200 per month as strategic priorities shifted toward the Pacific Theater and more advanced B-29 superfortresses. But April 1944 marked the moment when Charles Sorensen's impossible promise became undeniable reality. That month, employees working 2 9-hour shifts, 6 days a week, produced 453 airplanes in 468 hours. The mathematics were simple and stunning. One finished B-24 Liberator every 63 minutes, 24 hours a day, 7 days a week. The production rate that aviation experts had called fantasy, that traditional aircraft manufacturers had dismissed as impossible, that critics had mocked as the delusions of automobile men who didn't understand aviation, had become systematic reality. Cast Iron Charlie's brash claim of 1 bomber per hour was no longer an empty boast. Willow Run and its workers had met their goal through systematic application of assembly line principles to the world's most complex weapon. The quality statistics told an even more impressive story. Test pilots reported that mass-produced B-24 seconds from Willow Run performed identically to those built by traditional methods, but with greater consistency and fewer manufacturing defects. The precision jigs and automated processes eliminated human error while maintaining engineering tolerances essential for combat reliability. Bombers that pilots initially distrusted as Ford products proved themselves over Europe and the Pacific, absorbing terrible damage and bringing crews home when traditionally built aircraft might have failed. By the end of the war, Willow Run had produced 8,685 complete B-24 bombers, plus knockdown kits for an additional 1,893 aircraft assembled at Consolidated's Fort Worth plant and Douglas Aircraft's Tulsa facility. Ford built nearly 40% of all B-24 Liberators ever produced, more than either plant owned by the bomber's designer. The B-24 became the most produced heavy bomber in history, and Willow Run was the reason why. The human cost of this achievement was measured not just in bombers, but in lives transformed. 12,000 women worked at Willow Run, mastering jobs that traditional society insisted they couldn't perform. African Americans found industrial opportunities previously denied them, working alongside whites in an integrated production environment rare for 1940s America. Migrants from Kentucky, Tennessee, and West Virginia discovered that systematic training could turn farmers into precision manufacturers in weeks. Edsel Ford, the gentle leader whose steadfast support had made Willow Run possible, didn't live to see its triumph. He passed away on May 26, 1943, succumbing to cancer, though the enormous stress of the B-24 project undoubtedly affected his health. His father Henry, grief-stricken and increasingly erratic, couldn't maintain control of the company he had founded. By 1944, Henry Ford II, Edsel's son, had taken leadership of Ford Motor Company, inheriting an industrial empire transformed by war production. Charles Sorensen, the Danish immigrant who had sketched Willow Run on hotel stationery and driven its creation through sheer force of will, requested retirement effective January 1, 1944. His relationship with Henry Ford, once unshakable, had fractured under wartime pressures and the old man's declining mental state. Sorensen was 63 years old. He had spent 40 years making the impossible routine at Ford Motor Company. Willow Run was his masterpiece, the culmination of a lifetime spent perfecting the art of systematic mass production. He left Ford to become president of Willys Overland Motors, where he would transform the wartime Jeep into a civilian vehicle. But his legacy remained in Michigan, in the form of a mile-long factory that had proven democracy's industrial might could overwhelm any opponent. The King of Denmark knighted him and made him a member of the Order of Dannebrog for his accomplishments. The honor recognized not just one man's genius, but what systematic organization could accomplish when ordinary people were given the tools and training to achieve extraordinary things. The implications of Willow Run extended far beyond bomber production. Sorensen had proven that systematic mass production could handle products of any complexity if properly organized. The lessons learned at Willow Run would later transform into just-in-time manufacturing and lean production systems that revolutionized global industry. Toyota studied Willow Run's methods and built their production system on principles Charles Sorensen had pioneered. What started as a desperate wartime measure became the foundation for modern manufacturing worldwide. But in April 1944, as bombers rolled off the Willow Run assembly line every 63 minutes, the immediate significance was strategic rather than theoretical. Germany's Luftwaffe, which had mocked American industrial capacity in 1940, now faced aerial armadas that darkened European skies. Japan's military planners, who had gambled that American democracy couldn't sustain long industrial warfare, watched helplessly as bomber formations destroyed their cities and industries. The assembly line had become America's ultimate weapon, not because it produced superior technology, though American bombers were excellent machines, not because it demonstrated superior skill, though American workers were certainly skilled. The assembly line was decisive because it proved that democracy could outproduce tyranny through systematic organization of ordinary people doing extraordinary things. Every B-24 that lifted from Willow Run's runway carried a message written in aluminum and rivets, a message that said craftsmanship couldn't defeat system, that elite expertise couldn't overcome democratic organization, that totalitarian discipline couldn't match free people properly coordinated. Every bomber was proof that Charles Sorensen's impossible vision had become inevitable reality. By June 1945, when the last B-24 rolled off Willow Run's assembly line, the war in Europe was over, and Japan was months from surrender. The facility had produced more heavy bombers in 3 years than most nations produced in total during the entire war. It had transformed aircraft manufacturing from medieval guild practice to industrial symphony. It had demonstrated that American mass production, properly applied, could accomplish anything. The skeptics who had laughed at Sorensen's hotel sketches in January 1941 had long since fallen silent. The aviation experts who insisted aircraft couldn't be mass-produced had been proven wrong by mathematical reality. The critics who mocked Willow Runaround watched as one bomber every 63 minutes redefined what was possible in industrial warfare. Cast Iron Charlie had promised the impossible and delivered it on schedule. One Danish immigrant's sketch on hotel stationery had become the weapon that helped break Nazi Germany and Imperial Japan. The assembly line, that uniquely American innovation born on a Sunday afternoon in 1910, had proven itself the most devastating weapon of World War II, not because it killed directly, but because it made victory inevitable through the systematic application of democratic industrial might to the problem of aerial warfare. Germany could produce excellent individual aircraft through master craftsmen. Japan could build beautiful bombers through disciplined labor. But America could produce them by the thousands through systematic organization of ordinary people doing systematic work. That was the lesson of Willow Run. That was Charles Sorensen's legacy. That was democracy's answer to tyranny. Not superior courage or technology or skill, but superior system. Not individual genius, but collective organization. Not craftsmanship, but process. One bomber every 63 minutes. Built by farmers and housewives and migrants and teenagers, assembled with precision through massive jigs and fixtures that made skill automatic. Rolled onto runways where pilots flew them directly into history. The impossible had become routine, the skeptics had become believers, and the assembly line had won the war. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.